Welcome to TIPS Training and Certification online training program. Now we will study about the control charts under Six Sigma Green Belt training. What is meant by control chart? Control chart is a trend chart which monitors whether the process is in control or not. Walter Sheward invented the control chart. He gives the advance warning about the drift from the normal behavior. This is the main purpose of control chart. To draw the control chart for a process, we need to know the average and standard deviation obtained from the process. This shows the control chart. Here, upper control limit and lower control limit represented by dotted line, whereas the specification limit, upper specification limit and lower control specification limit are represented by a small line. Control limits are calculated by using the formulas, whereas the specification limits are set by the customer or design engineer. This is the example given related to the control chart. Here, the process is out of control as the 2 points are going outside the control limits. Why to use control charts? Because control charts let you know about how your processes are performing. They represent the voice of processes. Control charts provide an evidence for the stability that justifies predicting the process performance. Control charts separate signal from the noise so that you can recognize a process change when it occurs. How to determine the instability or out of control situation? This is by testing the instability in the process. We have to examine the control charts for the instances and the patterns of the signal. Values falling outside the control limits or unusual patterns suggest that these are the assignable causes. This is the control chart given related to X bar R chart. Here, for average, that is X bar chart, the points, the values are within the control limit, that is upper control limit and lower control limits. Similarly, for the range chart, all the points are lying within the control limits. Hence, from the both chart, the inference is the process is in control. This is another example of X bar R chart. Here, for X bar chart, 1 point is going out of upper control limit. What it means? The product or process is showing rejection for that particular point. In the range chart, 1 point, that is fifth point, is touching to upper control limit, which is the alarming point for that process stability. Control chart is also called as Sheward control chart as it is invented by Walter Sheward. Here, the basic concept about the control charts are given. The pink color line represent the target, that is mean of the process. Upper control limit is equal to target plus 3 standard deviation, which is represented by red line. Lower control limit is equal to target, that is mean minus 3 standard deviation, represented by blue color line. We have to see that all the values of that particular parameter of the process will lie between these two lines, that is upper control limit and lower control limit. Rational subgroup concept. What is meant by rational subgroup concept? Subgroups or samples should be such selected that if assignable causes are present, the chance for the differences between the subgroups will be maximized, while the chance for the differences due to the assignable causes within a subgroup will be minimized. Time order is frequently a good basis for forming the subgroups because it allows to detect the assignable causes that occur over a time. Two general approaches for constructing the rational groups. Consecutive units of production should be there. Random sample of all process output over the sampling interval should be selected. Control charts are of two types: variable control chart and attribute control chart. What is meant by variable? The values which we can measure. These are of continuous nature. The variable charts are X bar R chart, individual X and moving range chart, and second is your attribute chart, which means the values can be counted, not be measured. These are of types P, NP, C and U chart. How to choose the control chart? This is the process flow given to represent how to select the control chart depending on the situation. Mainly, the control chart is chosen on the two parameters. First is the data is variable or attribute, and second is there is defect or defective case. This is the explanation about the control chart. We will discuss this attribute chart and variable chart in detail in respective presentations. Interpretation of the control chart. What we have discussed earlier, if any point which is showing out of control limit pattern, then we can say there is a special cause of concern which we had to analyze for its root cause and take the corrective action. There are various patterns to judge the special causes of variation based on the control chart, so that by analyzing these patterns we can take the corrective action. Our first test is 8 or more points in a row on the same side of median indicates the process shift. This is shown in first graph. Second test is 6 or more points in a row continuously increasing or continuously decreasing pattern. This shows by the second control chart. Third test is 14 or more points in a row alternating up and down indicates bias or sampling problem. Our fourth test is 1 or more points outside the control limits indicates that something is different about those points. These both tests are shown in the respective control charts. Our next test for analyzing the control chart is 2 out of 3 point consecutive points beyond 2 standard deviation. Then we can say the signals a shift in the process. Next test is out of 5, 4 consecutive points beyond one standard deviation. This is shown in this control chart. 7 tests is 15 consecutive points within one standard deviation above or below the average, which indicates reduced common causes of variation, change in operation definition, or huge data. Last test is 8 consecutive points if lies beyond one standard deviation on either side, positive or negative, indicates overcompensation, multiple source variation, or fused data. Based on these 8 tests, we have to analyze the respective control chart, and depending on the patterns, we have to take the corrective action. The use of control chart, after all, should start with the management, not on the shop floor, as Edwin Deming says. Thank you.